Example 4. Deposits of $1,500 are made at the end of every quarterly period for 20 years. If the interest rates are 9.4% compounded quarterly for the first 15 years and 12% compounded quarterly for the remaining 5 years, determine the accumulated value of the deposits at the end of the 20th year. So what you'll notice here is that the interest rate changes. It is one rate for the first 15 years and a different rate for the last 5 years. So what we have here essentially are two different annuities because these are annuities that earn different rates. The payments are $1,500, however, the rate changes, and so we have to separate them into two annuities. This is a little bit more advanced, so let's approach the time diagram with caution here. We've got 15 years of quarterly deposits of $1,500, so that amounts to a total of 15 times 4 deposits per year. So we're looking at 1, 2, 3, 4. 15 times 4 is 60 quarterly deposits of $1,500. So let's set up our time diagram here. So our payments are $1,500 per quarter. So we've got 60 quarterly deposits of $1,500. That's our first annuity because this annuity earns interest at a rate of 9.4% compounded quarterly. So we've got an interest rate of 9.4% compounded quarterly for this 15-year annuity. Now the second portion for the last 5 years, we've got again $1,500 deposits. So we've got 0, 1, 2, 3, but 5 years only. 5 times 4 is 20 quarterly deposits of $1,500. So we've got $1,500 per quarter. Again, $1,500 per quarter for a total of 5 years. So in this particular annuity, we have a total of N is equal to 20 deposits, 20 quarterly deposits, but the interest rate is different. The interest rate is 12% compounded quarterly. So again, to summarize, we have a total of N is equal to 60 deposits for the first 15 years, and we've got N is equal to 20 deposits for the last 5 years. So in other words, a total of 80 deposits over the 20-year period, but the rate changes. Now, what do you think we're going to do first? First step, let's figure out what the final value is of the 60 deposits of $1,500 at the end of the 15 year. That final value is going to be given by $1,500 multiplied by the annuity factor for 9.4% compounded quarterly. Now 9.4% divided by 4 quarters per year is going to be 2.35% per quarter. So that's going to give us a maturity value of 1.0235. Power is positive 60 less 1 divided by 0.0235. There's our annuity factor. That's going to give us the maturity value of the $1,500 plus the accrued interest at the end of the 15th year. That maturity value will work out to be $193,000. The final value works out to be $193,000, $383 and 98 cents. And that's the value at year 15. This is absolutely critical. It's the final value on the date of the last deposit of $1,500. That $193,000 includes the $1,500 deposits plus the interest up to the 15th year. Now, what can we do for our next step? Well, I guess one thing that we can do is calculate the final value or the maturity value of the last 5 years of deposits. Let's do that. So the final value of the last 5 years is going to be determined by, well, let's see, we've got $1,500 quarterly deposits, so it's $1,500 multiplied by the annuity factor for those quarterly deposits at 12% compounded quarterly. 12% divided by 4 quarters per year is going to give us an interest rate of 3% per quarter. So the annuity factor is going to be 1.03. Exponent is positive 20 because there's 20 quarterly deposits of $1,500 minus 1 divided by 0.03. And so when I work this out, multiplying the payment by the annuity factor, we end up with a value of $40,305. $2,242.56. And that's the value at the end of year 20. At the end of year 20, or in other words, at the end of the 5th year of the deposits. And that is an important piece of information. How are we going to handle these two pieces of information on our time diagram? First of all, the $193,000 belongs at the end of the 15th year. So on your time diagram, you should indicate that the $193,000 belongs at the end of the 15th year. And the $40,000, the 40K, belongs at the end of the year 20th. So 40K belongs here at the end of the 20th deposit. If we want to determine the accumulated value of the series of deposits over the full 20-year period, do we simply just add these two amounts? The answer is no, we don't, because $193,000 does not have a value of $193,000 at year 20. It certainly will earn interest. It'll earn compound interest for the next 5 years. So because this earns interest, we will recognize that and add compound interest for that 5-year time period. How does it earn interest? Well, it earns interest at a compound interest rate. So we're going to use the maturity value formula for compound interest. Multiply P by 1 plus I to the exponent positive n. So we're going to take the $193,000 and add compound interest to it at the rate that's in effect for that 5-year period of 12% compounded quarterly for the last 5 years. And then we can consolidate that with the other annuity, which is the 5-year annuity earning interest at 12% compounded quarterly. And so if we take the $193,000 and multiply it by the compound interest factor for the last 5 years, we will end up with $193,383.98 multiplied by 1 plus 3% per quarter for 20 quarterly deposits. That's going to give us a maturity value of $349,349 and $272.99. So at year 20, this $193,000 will amount to $349,000. So I'm going to indicate that as 349K. So now we have the first annuity accumulates to 349K at the end of the 20 years, and the second annuity at the other rate, the 5-year annuity, accumulates to an amount of $40,000 at the end of the 5th year. Now we have them both at the same focal date, and now we can simply add them. And so for the grand total after the 20 years would be the 349K plus the 40K. That gives us a grand total of $389,578.55. That is the total amount of the deposits with interest at the end of 20 years. And so, if we were asked the question, how much of that $389,000 is interest, it would be a very easy calculation for us to work out. First of all, the $389,000 includes the interest. The amount that doesn't include the interest is our deposits, and we've made a total of 60 deposits of $1,500, which adds up to $90,000. We made a total of 20 deposits of $1,500, which adds up to a total of $30,000. So without interest, we made a total of $120,000 in deposits. So without interest, we've got $120,000 into that account. That means that if I subtract $120,000 from the total with interest, I can then conclude that the total interest on this investment is equal to 389 minus 120, or $269,578.55. For the last example, we are not going to solve it for you. We're going to let you solve it, but we'd like to set it up with you. Deposits of $3,000 are made at the end of each 6-month period into a retirement fund for 8 years. At that point, the deposits change to $600 per month for a further 8 years. Determine the accumulated value of the deposits after 16 years if the rates are 9% compounded semi-annually and 10% compounded monthly for the first and second 8-year periods. The first thing I would recommend doing is to set up a time diagram showing the first 8 years of semi-annual deposits. Semi-annual deposits means that there are 16 semi-annual deposits of $3,000 every 6 months, and for that 8-year period, the interest rate is 9% compounded semi-annually. Then we could also follow that with another 8 years of monthly deposits of $600. 8 years of monthly deposits means 96 monthly deposits. The interest rate for that 8-year period is 10% compounded monthly. There are several steps in order to solve this problem. Determine the future value at the end of the 16 years. We obviously have to find the final value of each of the separate annuities and then do something to those two final values in order to compute the final sum at the end of the 16 years. Have a try at this problem and see if you can do it.